Ever pondered the implications of an increasingly crowded sky above us? Let's take a moment to consider the surge of satellites, particularly in low Earth orbit. We're not merely talking about a few dozen or hundred, we're discussing thousands, with constellations like Starlink leading the pack. Over the past few decades, the number of satellites has skyrocketed, painting a picture of a sky teeming with man-made celestial bodies. In the 1990s, we had just around 800 satellites. Fast forward to today, and we're looking at a staggering 30,000 plus satellites, with numbers projected to increase exponentially. This sudden influx raises several questions. How are we managing this celestial traffic? What measures are in place to prevent collisions? More importantly, how is this impacting our view of the cosmos? With the stars now sharing the spotlight with these gleaming satellites, what effect does this have on astronomical observations? What could be the potential consequences of this celestial traffic jam? Stay tuned as we delve deeper into these questions. Have you ever thought about how this satellite boom might interfere with the work of astronomers? Well, it's a growing concern among the stargazing community. You see, as the number of satellites in low Earth orbit skyrockets, they're beginning to crowd the night sky. And with every new addition, there's an increased chance of these satellites causing what we call light pollution. This is where the artificial light from the satellites outshines the natural ambient light in the sky. This light pollution poses a real problem for astronomers. Imagine trying to capture a long exposure image of a distant galaxy, only to find the image streaked with the trails of passing satellites. It's like trying to listen to a symphony with a jackhammer going off in the background. And it's not just about pretty pictures. This light pollution can interfere with scientific observations and research, making it harder to study celestial objects and phenomena. Take, for instance, the case of the Hubble Space Telescope, which was blinded by the glare from a large constellation of satellites. Or consider the time when a team of researchers studying the dimming of a distant star had their data muddied by satellite trails. These are just two examples of how increasing satellite numbers are hampering the efforts of astronomers. So, is there a way out of this predicament for astronomers? Fear not, for every problem there's always a solution in the making. The rapid rise of satellites crowding the low Earth orbit is indeed a concern, but it's not a situation without potential solutions. One such solution lies in the realm of technological advancements. Scientists are exploring methods to minimize satellite visibility, such as using materials that absorb light instead of reflecting it. This could significantly reduce the interference caused by satellite streaks in astronomical observations. Another solution is responsible satellite constellation implementation. This means deploying satellites in a way that minimizes their impact on astronomy. For instance, companies like SpaceX are already working on adjusting their satellite orbits and timings to avoid peak observation times, thus reducing their obstruction of the night sky. But technology and corporate responsibility alone may not be enough. Policy changes are also crucial. Regulatory bodies around the world need to enforce stricter rules about satellite brightness and quantity. This could include implementing a limit on the number of satellites in low Earth orbit, or requiring companies to use technology that reduces their visibility. Just imagine a future where we can have the best of both worlds: a sky full of stars for astronomers to explore, and a sky full of satellites, providing global connectivity. A balance is possible with thoughtful and informed solutions. While these solutions are not perfect, they represent a step in the right direction. So, what does the future hold for our starry nights? As we've discussed, the surge in the number of satellites in low Earth orbit is a modern marvel. Yet it's not without its challenges. These celestial commuters, while providing technological advancements and connectivity, have inadvertently become stumbling blocks for astronomers. Their bright trails often interfere with astronomical observations, muddying our window to the cosmos. But all's not lost. Potential solutions are already in the works. From dimming the brightness of these satellites to developing advanced algorithms that can filter out their interference, we're finding ways to coexist with our artificial celestial neighbors. As we continue to populate the low Earth orbit, it's vital that we strike a balance between our thirst for progress and our innate curiosity about the universe. As we reach for the stars, let's ensure our pursuit of progress doesn't eclipse our ability to marvel at the universe.